Actually, let's just call it day 2. Yep. But label it, it'll probably count as a section. Label it. Yeah, we'll do day 2 here.
Day 1 in front of the other one?
No, that's alright. We'll figure that out.
It's too late, I already did.
That's fine there too. I'm so flexible, it's crazy. All not important stuff. Okay, let's quickly review the z-score thing. That formula. Remember, z-score tells you how many standard deviations away from the mean you are. Typically, what should our z-scores fall in between? What 2 values? How far away from the mean does most of normal data stay?
0.
-3 to +3. Typically, our z-scores are in there. 99.7% of them are between -3 and +3. And how do we get a z-score? Take the x value, subtract the population mean that they tell you, and divide that by the standard deviation that they tell you. Okay, the very last, I think, 1 or 2 problems you had you given a z-score, what was that x value that it started out as? And you work backwards. Okay, let's write that formula down so everybody else has it, just in case. So how do I work this backwards and solve it for x?
Multiply by standard deviation.
Multiply by standard deviation, so it's going to be the z-score that gets multiplied by the standard deviation. And then what? How do I solve for x? Add the mean. So z-score times standard deviation plus the mean. So those are your 2 formulas that you will use for this entire chapter. The entire chapter. Very important formulas there. Okay, I want to go back to that. Let's see, I'm going to go through an example here. Convert the utility bill graph and our utility bill was the example we had. The mean utility bill was $70. The standard deviation was $8. And we made the graph, and I'm just going to copy it from the notes from Monday. 7 key values. So we had the 70 in the middle. That was our mean. And then we add on a standard deviation to go up those 3 steps. So I've got 78. I got the exclusion in here. 78, 86, and 94. And then we subtracted the 8 to go down. So that gave us 62, 54, and 46. Okay. Yep. Well, unless, because we're going to write, now it says convert the utility bill curve into z-scores. And this should not be very difficult. In other words, I want to turn these 7 key values into z-scores. You shouldn't have to use the formula here. It should be common sense. What is the z-score for 70? 0, because it's right on the mean. It's not away from the mean. What's the z-score for 78? How many standard deviations away from the mean is it?
Not even 1.
86 is 2 away, and 94 is exactly 3 away. Do I need the formula here? No, because they're landing right on those. So what is 62 going to be? -1, -2, and -3. Could we convert all data into z-scores, no matter what the graph is?
Yes.
Yes. And when we do that, what we create is called the standard normal curve. the standard normal distribution. This was a normal distribution. Now we're talking about the standard normal distribution. All data values are converted to z-scores so the mean will equal 0 and the standard deviation will equal 1. So there's only one standard normal distribution, but there's a lot of normally distributed data. Okay, our whole goal today is going to be to find the area under the curve which corresponds to probability. So, and we've got two ways to do it. There's a table we can use, and then there's a function on our calculator. And I like to do things both ways, because if you do have to take this class again in college, which most of you will, Ashley, most of you will, take a stats class, because it's in almost all of the curriculums out there. I don't know what you're going to be doing, tables or calculator stuff. College professors are all over the map on this, so I do everything both ways, so at least you've seen both ways, and I kind of lean toward the calculator afterwards. But okay, so what we're going to do is find area under the standard normal curve by table first. And this table is on the front cover of your book, or it's in the back index somewhere. I always use the front cover one. And it's a 2-page table, so you need your book handy.
Oh my God.
It's 2 pages. It's the left cover and it's the right page in. Oh yeah, we're going to learn how to read this table.
Wait, what are
So
these?
get this out.
What are these?
What?
What are these for?
What we're going to do, finding area under the curve. I haven't showed you how to do it yet. Just showed you with a table. Front cover.
I know.
Front cover.
It's gonna go over. It's in the back too.
It's in the back in the index somewhere, like A21 or something, if I remember. A18, actually, I wrote down. Page A18 or the front cover. Okay. The way, listen, the way the table works. If you look up a z-score, when we look up a z-score on that table, it's going to give you the area behind that z-score. It's going to tell you how much area there is to the left, total. So this is what you're going to see in the table value. Yep. So, are you ready to do this? Come on. I'm excited here. They're the same, oh, because the top numbers are different. I'll show you. Because the table goes out to the hundredth place. Okay, you ready? We're going to learn how to read the table, Ashley. This is good stuff. Not yet. So, okay, here we go. Let's go example 2. Find the area to the left of each of these z-scores. Negative 1.63. I'm going to do a little sketch just so you can see what you're finding. Not that the sketch is at all needed. Remember the z-score on the mean is 0. Negative 1.63 is about here. Negative 1.63. And I want this area to the left of that. And I'm going to find that area on the table. Okay, you ready? Looking for the table under here now? Okay, the left-hand page has your negative, and I gave you negative 1.63. So if you look, the z-scores are out to the 10th place here, so I find negative 1.6. And then if you look across the top row, these are the numbers that are in the hundredths place. And what number's in my hundredths place? The 3, so I want to go to this spot. So if I put those together, that would be, if I added them, that would be negative 1.63. So then I just look for that intersection.
Oh, that's not so bad.
No.
I thought that
That's
was
how
gonna
much
be like
area
way
there is to the left of that z-score, or just a little over 5% of the graph.
So it's to the left once you go to the.
Always, so this table value is always to the left.
Okay.
I'm going to ask you for areas to the right and areas in between here in a minute, but, okay? So it's about 5% of the graph is to the left, 0.0516. Try one more. What if I give you to the left of 2.79? Where is 2.79 on my graph? That's way out here to the right, almost to 3 standard deviations above. And I want the area to the left. Okay? So we look up 2.79 and read that value.
We don't have to know the graph.
No, I just like to show you what we're finding. So I'm going to find the 2.7, positive 2.7. And then I've got the 9 in the hundredths place. So that's way over here on the end. So I want the last number there. You can read this table? You guys are good?
I actually really like it.
Okay.
I bet it gets harder. Everything gets harder. Don't rush with me.
Okay. I think I want to...
I heard
If the area to the left,
Am I gonna need a lot of space?
nope, of a z is 0.985, what is that z-score? Okay, this time I'm giving you the area and asking you for the z-score. Before we look it up, is this z-score going to be positive or negative?
Don't say positive.
Why positive? Above what?
0.5.
It's above 50%. Remember the 0 line, half the graph is there, and then these are all negative z-scores. If I'm over 50%, I'm into the positive z-scores. How do I find that?